Assalamu alaikum. Today we will discuss about how to write the Matlab or Octave program for calculating the electric field due to endpoint charges. After that, we will find out how we can compute the energy due to the endpoint charges located in space according to the Cartesian coordinate system. So first we will go to the first problem. Okay. So first I will discuss about this particular problem. This one. Okay, I will first discuss about this problem. So for that I am going to open this software which is known as Octave. Okay, Octave, and sorry, I will open the software Octave. So this is the graphical user interface for the Octave. Okay, so I will first open the location where I have written these programs. So here is my program. So electric field program first I will open. Okay, it's very simple. Now I am considering 2-point charges. So I have considered n is equal to 2, and before that I have cleared all the variables. So this will clear all the variables in the memory, and close all means it will close all the figures which are opened. So I am assigning what is q, what is n. N is the number of charges. So I have considered only 2 charges. So my first charge. So this is the charge actually q. So all the charges are actually given as a vector. You can see as a matrix. You can see. So the first charge is 5 into 10 power minus 6, and the second charge is 10 into 10 power minus 6. Okay, or I can change it to 12. Okay, or 13 into 10 power minus 6. Next, x1, y1, z1. I am giving a variable x1, y1, z1, and this variable is 2, 1, 4. What is this? This is the coordinate. Actually, this is the coordinate for the first charge. So for example, the first charge is located here. Okay, so the first charge is located like 2, 1, 4. So this is located at 2, 1, and 4. Okay, so this is the first charge, location of the first charge, and the second charge is located at 1, minus 1, 2. So this is the second charge is located at 1, minus 1 and 2. Okay, 1, minus 1 and 2. So this is the location for the second charge. Now I want to calculate what is the electric field at the point xyz. So this is the point xyz. So xyz point means minus 2, 3. So this is minus 2, 3, then I think 1. So I want to find what is the electric field at this point. So here, what is the electric field? So in the first point I have the charge 5 into 10 power minus 6. So here the charge is 5 micro. Okay, and here the charge at x2, y2, my charge is 13 micro. So 13 micro coulombs, and here it is 5 microcoulombs. Now I want to find what is the electric field at this point. So this is what the question. So for that, first I will find the constant. That means 1 by 4 pi epsilon 0. So I am substituting it. You can see 1 by 4 into pi into 8.854 we can say, into 10 power minus 12. So after that I will find what is the electric field at this point due to the first charge. Then you know the formula. Electric field due to the first charge means I will take the first value from the charges, because I have defined my charges by using a vector or a matrix, you can see. So I will take the first value, that is the first charge. Then I will find what is the vector which is connecting. What is the vector which is connecting like this in this direction? What is a vector? So I can take the point. This is xyz. You can see this point is xyz minus x1, y1, z1. So that is a vector divided by the norm. Norm means it will give you the magnitude. It will give you the magnitude. Then the magnitude of that vector whole power 3. So this will give you the first electric field. The second electric field you can calculate in the same way, but you have to consider the you have to consider, for example, you have to consider like this. You have to consider like this. So this is the connecting vector. So you will consider like this. Okay. So x minus x2 y2 z2. Then you will find the norm and take the cube of this. Then the total electric field is equal to E1 plus E2. So let us run this program. Okay. So I have written this program in the editor window. So when you open the Octave, you will see the editor window actually here like this. So I have written the program actually in the editor window, not in the command window. So this is the editor window you see here. There are two types of windows that I have introduced in the first video. This is the command window and this is the editor window. Okay. Now if you want to write the program, you have to go to the editor window and open a new file. Then you can write the program and save it. So I'm going to run it. Now I have written the program in a different folder. I am going to change the directory. Now you see my programs are here. This is my first program. So I'm going to run it. When I run it, I need to see the results. So I will see the results here. So you see here, the charges are the first charge and this is the second charge. And the coordinate of the first charge, this is the coordinate of the second charge. And this is the location where I want to find the electric field. So this is the first electric field due to the first charge at the point x, y, z. This is the electric field. That means you see three coordinates. So you see these three coefficients. The first coefficient is representing the component in the direction of x. The second is showing the component in the direction of y. And the third one is showing the component in the direction of z. And similarly here also for the electric field E2. You will see this is for in the x direction, y direction and the z direction. So what is the total electric field? You see here, this is the total electric field. This is like in the x direction, y direction and the z direction. Okay. So this is what the answer. So it's a very simple program. Okay. Now you can write the program. You can just modify this program for n equal to 5. So you have to include 5 charges. So you have to compute, you have to give some arbitrary position. For example, you give some arbitrary position like x3, y3, z3 as you like, whatever you like. Okay. And then you can check this program. Okay. So you can proceed in the same way. So I hope it is clear to you. Then the second problem, it is like computing the second problem. This one is the second problem. So this problem is to compute the energy density, or sorry, not energy density, energy due to the charges in a space. So I will just open this program. I have written a sample program for this. So you can see here the first line, we are again writing in the editor window. You can open a new file and then start writing the program. Okay. So this is what the program that I have written. You know that the formula for finding the total energy is Q1 V1 plus Q2 V2 plus Q3 V3. So first of all, we will find what is Q1 V1 and Q2 V2 and Q3 V3. So for that we need to define the coordinates. So you can define any coordinates as you like. It is up to your choice. Okay. So I have 3 charges anyway. I am not mentioning the number of charges here anyway. This is not needed. Now first of all, it will be clear all. I will clear all the variables which are stored in the system. Then close all. Then I define 3 charges. This is first one is the Q1. Then it is the Q2. Then space. Then it is the Q3. So the coordinate of the first charge is x1, y1, z1. Then the second charge is x2, y2, z2, and the coordinates of the third charge is x3, y3, z3. Then I find the constant, because we know we need this constant always, k. So if I am finding this constant initially itself, then it's very easy to calculate. So first of all, I will calculate Q1 V1. You know, Q1 V1 can be calculated as k into Q1. Then when I talk about V1, it is the potential at 1 due to other charges like 2 and 3. So the potential due to other charges is nothing but k into Q2 divided by the norm of that charge. Similarly, uh, for I will find the electric field at 1, not electric field, the energy, sorry, yeah, voltage at 1 due to the Q3. So we can use the same formula. Okay. Similarly, we can find for Q2 V2. Q2 V2 can be found like we have first Q2, then to find V2, V2 is the potential at 2 due to the charges 1 and 3. So you see here we will see 1 and 3. Okay, so it is a potential at 2. So we want to find what is the connecting vector from 2 to 1. That's why I am using x2 y2 z2 minus x1 y1 z1, and I am taking the absolute value, not absolute value, the magnitude of that vector. Okay. Similarly, I will find what is the potential at 2 due to the charge 3. That's why. So please note these notations very carefully. Similarly, I will find for Q3 V3. So this idea can be used for any number of charges. So if you have 5 charges, you can extend this program for 5 or 6 charges. Okay, and you can give arbitrary position coordinates. So you can find the total work done or total energy is equal to Q1 V1. That means the first variable plus second variable plus third variable. Okay, so this is how to proceed. So let me run this program. So you see the total energy is 2.7461 this much joules. Okay, so I hope it is clear to you. Thank you.